Hi guys! In this video we're going to talk about determinants, inverses, and solving systems using matrices. First of all, let's talk about what a determinant is. Every square matrix, just the square ones, have a value that is called the determinant. And all we want to do is figure out how to find the determinant, okay? In other classes, you may use the determinant to solve a system or to help with finding the inverse. In this class, I just want you to know what the determinant is as far as can you find that value, okay? So the first thing that we're going to do is we're going to do this by hand. So if you want to do it by hand, you take the product of the main diagonal entries. So in this case, 1 times 3, 1 times 3, and that gives us 3. And you subtract the product of the other diagonal from it. So this diagonal, 4 times negative 2 is negative 8. So we subtract, we take the 3 and we subtract 8 from it, a negative 8 from it. Okay, so in this case we should have 11 as our determinant. And the way that we can check this on the calculator or use a calculator to figure it out, first, turn on your calculator, go to your matrix area, go to edit, and we want to edit matrix. It doesn't matter which one you put it in. I'm going to put it in A, so that's where we are right now. And I am going to, it's a 2 by 2 matrix. We're going to put this one from the top in. 1, 4, negative 2, and 3. Okay, quit the screen. Now go back to your matrix. And you want to go over to math. DET is for determinant. And then go get matrix A, or the matrix that you put wherever you put your matrix in. You don't have to close the parentheses. I just like to sometimes. Okay, and 11 is correct. So we did our stuff correctly. Now let's talk about what an inverse is. So in terms of matrices, if you're given a matrix, you can write its inverse with a superscript -1. So like this right here, it's saying, hey, this is the inverse of matrix A. Okay? If you multiplied, let's just think back to our original starting the year off. We were talking about identities and inverses. And in the last video, you learned about the identity matrix. Well, now let's talk about the inverse. Remember, if you multiply a number and its inverse together, multiplication, you multiply its inverse, a number and its inverse, you get 1, because 1 is the identity, okay? So you'll always get the identity. Well, think about this. When you multiply a matrix and its inverse together, you should get the identity matrix. And there are only special times when this works. It only works with square matrices and when the determinant does not equal 0. So if the determinant of the matrix equals 0, it cannot have an inverse, or it does not have an inverse. All right, so let's find the inverse of a matrix. We're going to do this on the calculator. Well, first we need to put the matrix that we're given in the calculator. So go second matrix, go over to edit, and I always go to matrix A. We're going to do a 2 by 2 here, which is mine is already set up for. 3, negative 2, 1, and 0. And quit that screen. Okay, now let's go back and get the matrix that we want to work with, which is matrix A. And then all you have to do on the matrix button, when you usually hit second and the x to the -1. This time you just want to hit the x to the -1 button. That way it says, hey, here's the inverse, and that looks like the format of what the inverse looks like. And then hit enter. That is your inverse. I'll put it back. Let's see. Put it back there. All right. And so the inverse, we'll call it w to the negative 1 is 0, negative 0.5, 1, and 1.5. Okay? And then the next step says now find the product of w and its inverse. So I have what they're calling w stored in as a. Okay? That's what I typed in for a. So all I need to do is take matrix A and multiply it, which again, I don't have to put the symbol of an x in there for multiplication, but I need to multiply it by its inverse. So go get A again, and then put the inverse, and now enter. And look at what we have, a square matrix where 0 are the entries except in the main diagonal, in which we have 1. This is called the identity matrix. So W times W inverse equals the identity. Now, you can use this to help you solve systems. You just set up an equation. Okay, so first we want to use the coefficients from this system. We're going to try to solve for x and for y just like you learned in the last section, but you were doing all of this by hand. We're going to use the coefficients to create a matrix, and we're going to name it A. So for matrix A, it should look like this: 1, 1, 2, and 3. I got these values from here. The coefficient in front of x is understood to be a 1, so that's this first one. In front of y is also understood to be 1, so I got that one. In front of x here is a 2, and in front of y here is a 3. Okay, so that's matrix A, and that's only with the coefficients. Now we just make a variable matrix. It's just a general matrix saying, hey, I'm using x and y in this equation, so I'm going to set up an x and a y matrix, and I'll call it x. Use the constants to create the last matrix and name it B. So the constants are on the other side of the equal sign. It's the 4 and the 9 here. Now, if your system was not set up in standard form, you'd want to do that first. Okay, so far we have this information. Now, if you look to your next page, if you will recall, if you're solving a problem, in order to get rid of A, we say divide by A, but that is the same as multiplying A by its inverse. If I multiply A by its inverse, it's 1 over A, which is the same thing as dividing by A. And I have to do both sides by its inverse, okay? A times 1 over A gives us 1, right? The identity. So that's why it works there. So we'd multiply by its inverse, and then we would simplify and solve, okay? Same thing with a matrix, or with matrices. If I have a matrix A times a matrix X equals some matrix B, in order to solve for X, because that's the one that's holding our variables, in order to solve for it, I need to multiply A by its inverse so that I can get X alone. So I'll multiply by its inverse. The trick here is you always need your inverse matrices to go first when you're multiplying, because remember those rules about you can only multiply matrices if the columns in the first match the rows in the second. So you need to be careful with that. Always do the inverse first, then the other matrix. Now, no matter what, you should get the identity because a matrix times its inverse is the identity. Just like a number times its inverse is 1. Same thing. So we have the identity times x, which is just the x matrix, equals whatever this information is. So let's look at how this looks using our information. I am looking back at the other page, and I see 1, 1, 2, 3. That's matrix A. Times B, which is, times x. X times y, or xy there. This is the x matrix. So if I multiply those together, I'll get B, the 4 and the 9, the constant matrix. Now all I need to do is get rid of this. You're going to do all of this in the calculator. You don't have to write anything more down. Let's go back into our matrix edit. We're going to edit matrix A, and it is a 2 by 2, and it's 1, 1, 2, 3. We do not need a matrix X. Okay, we don't need a matrix X, but we do need a matrix B. Go to matrix B. Oh, not here. Go over to edit matrix B. It is a 2 by 1. 4 and 9. Okay. All right, now here's where it gets good. Go back up to this. We've got a matrix A and a matrix B plugged in. If you do all of this work with the inverse, you should get to this final step here. So we need to take the inverse of matrix A and multiply it by matrix B. Go get matrix A, make it the inverse by pressing the negative x to the negative 1 key, and then go get matrix B and press enter. That is your solution to this system. The x, because x was on top here, the x is 3 and the y is 1. So your answer for the variable matrix is 3, 1, and you could also write x equals 3, y equals 1. And that's all for this video. We will do practice problems in class, so ask me any questions that you have. See you later.